Your regression line fits well, but do the errors fan out? The Koenker-Bassett test, a robust test for heteroskedasticity. Imagine the price of 40 homes regressed on their size in square feet. Bigger homes cost more, so we fit a straight line by ordinary least squares. The line explains 77% of the variation. So far, the model looks healthy. The key idea: take the leftover errors, the residuals, and plot them against the price the model predicted. If the variance were constant, this cloud would stay the same width all the way across, but it doesn't. For cheap homes, the errors are tiny, and for expensive ones, they swing wildly. The spread grows with the predicted value. That widening funnel is exactly what heteroskedasticity looks like. How the test works: it runs an auxiliary regression. We try to predict each squared residual from the fitted values. If the squared errors really do climb with the fitted price, that's a sign the variance isn't constant. And because Koenker and Bassett use studentized residuals, the test stays valid even when the errors aren't normally distributed. The formula: the test statistic is the sample size n times the R-squared from that auxiliary regression. With 40 homes and an auxiliary R-squared of 0.22, we get a chi-squared statistic of 8.68 with 1 degree of freedom. Under the null of constant variance, this follows a chi-squared distribution with 1 degree of freedom. How to interpret it? Our p-value comes out to 0.003. That's well below 0.05, so we reject the null of constant variance. The residuals are heteroskedastic. The funnel we saw was real. Here's why it matters. Your slope estimate stays unbiased, but the standard errors are wrong, so your p-values and confidence intervals can't be trusted. The fix is to switch to robust standard errors, or weighted least squares. Use it whenever you're checking a regression for non-constant variance and can't assume normal errors. It's the robust upgrade to the classic Breusch-Pagan test. For more general patterns, White's test casts a wider net. Run the Koenker-Bassett test free at metricgate.com.